So this is Miss Rivera, and I'm doing a couple of videos for students that have not been in class lately because of games and things, and also to help some of you who seem to have a hard time with the factoring and solving equations. So the first thing in 5.3 that I really want you to think about is that you now have a bunch of strategies for solving equations. You can take out the greatest common factor. You can solve by square roots. You can do simple factoring, right, when you have ax squared plus bx plus c. If a equals 1, then you can just factor that easily. You can do factor by grouping, completing the square, or the quadratic formula. A lot of times from here on out, it's not going to be as often that I'm going to say do it one way or another. It's just you need to know what is the easiest way to do. While many of you have programmed your calculator to do the quadratic formula, there are still a few other processes that I want you to know how to do. Checking it on the calculator is always a good way to make sure that you've done it correctly. So there are some special patterns that at this point you should know and you should be able to recognize. The first one, and one of the most important ones, is a squared minus b squared. A squared minus b squared will always factor to a minus b, a plus b. So if I have x squared minus 9, I should know that that is x minus 3, x plus 3. We talked about these a lot when we were working with imaginary numbers, because that's what we use to find the conjugate to get rid of the imaginary part. Other patterns that are important are if you have a plus b times a plus b, and sometimes we will write that as a plus b squared. This is what it will multiply out to, okay? So where this is a pattern to factor, this is a pattern where we're multiplying. The same goes for a minus b. A minus b squared is distinctly different from a squared minus b squared, and you need to keep these processes in mind, okay? If you were to FOIL this, you would get this one. When you have a binomial and you're adding a squared plus b squared, you're done. You can't do any more. You're factored, okay? So there are 3 more that you're going to need to know how to use. The first one is a difference of cubes. The second one is a sum of cubes. And what does this mean? What this means is if I have a cubed minus b cubed, if I have this, I can immediately substitute and plug it into this pattern. What makes this easier is that I don't have to figure out how to factor it. If I learn this particular formula and this formula, then I immediately know what to go to. If I have a sum of cubes, which means I'm adding 2 perfect cubes, then I know I can factor it just like this. Again, this is not meant to confuse you. It's meant to give you a tool where you can recognize a pattern and immediately plug it in. Okay, so let's walk through this. If you can make your function look like a cubed minus b cubed or a cubed plus b cubed, then you know how to factor it. If I have x cubed minus 64, I can rewrite that as x cubed minus 4 cubed, where a is equal to x and b is equal to 4. Then I can just simply put it into my pattern, x minus 4, x squared, plus 4x plus 16, and I know that I can solve that using my zero property principle. Once I do that, I can say that x minus 4 over here has to equal 0. There's one root, or the second part can be put into the quadratic formula. You might want to pause for a moment and see how we solve that. You'll notice that you will always get one real root, and you'll always get a set of complex roots. So the key to being able to factor a difference of cubes or a sum of cubes is to recognize that that's what they are. Okay, so let's look at this first one right here, where we have 125x cubed minus 27 is equal to 0. If I rewrite it as 5x quantity cubed minus 3 cubed, then I can plug it into my formula saying that a is equal to 5x and b is equal to 3. If I have x cubed plus 8, I can rewrite that to be x cubed plus 2 cubed. Then a is equal to x and b is equal to 2. Remember that you're always substituting into the formula the cube root, not the number that appears, well, that's great, not the number that appears in your initial problem. You want the cube root to go and be your a's and b's. Okay, so if I have 125 x cubed plus 216, I can rewrite that as 5x quantity to the third plus 6 to the third. One way to find your cube root is to use your calculator. If you put your number into the calculator and you use the caret key and the 1/3 power and hit enter, it will tell you if it's a perfect cube. A perfect cube would be an integer. Not a perfect cube means that it's 2.3987. That's not a perfect cube. You know you need to do something else. So now that I have it written as a sum of cubes, all I have to do is just simply put it into my formula. That's all it is. Memorize the formula, plug it in. That's all you have to do. I find that 5x plus 6 is going to be one factor. 25x squared minus 30x plus 36 is going to be another factor. As you can see, this one is quite simple to solve. This one a little more involved, and it's only just using the quadratic formula. In the end, I should have a pair of imaginary or complex roots and a single real root. I have to have 3 roots because, as you remember at the very beginning, we have 3 for our highest exponent. Your largest exponent will tell you how many real and complex roots are going to be in your solution. When a cube root is factored, you will get 1 real root and 1 complex pair, always. So you'll always have to solve this simple one, and then here your tricks that you can use are the quadratic formula or completing the square. So what I want you to do at this point is stop and go to your assignment on Orban and do the assignment for 5.3 that only has to do with sum and difference of squares, okay? There's a second part to it, but I want you to do that part first so that you can understand how to factor and solve these.